All right, this is going to be my second take on this because I actually completed all these videos for Unit 5 without actually recording what I was writing. So you get the audio transcript and you get me looking like I'm writing, but you don't actually get the writing. So this is take 2. And that means that I will not be writing on this printed out copy. Instead, I'll be doing what you will probably be doing, which is writing each problem down on your paper. So I'm going to jump around and I'm going to go out of order, but I'm going to start my video with problems 1, 2, 6, and 10. So problem 1 says to write an equivalent expression to 3x to the 8/5 power in radical form. So to get this into radical form, all that I'm going to do is I'm going to take the base 3x, I'm going to keep the numerator of its power 8, and then I'm going to take the denominator of its power and make the denominator the radical. That's it. That's the radical form. Now we are going to also simplify. And so when I simplify, I'm looking for groups of size 5. So groups of size 5 because that is the 5th root. So I want groups of size 5 to come out of the 5th root. Well, I've got 8. So 8 has one group of size 5 with 3 leftovers. So I have one group with 3 leftovers. And I can go ahead and reduce that one step further and rewrite it as 27x cubed, because I say 3 cubed x cubed, 27x cubed, and we're done. All right, so there's number 1 written in radical form. We're going to do more simplification with number 2. So number 2 has the cube root of 64, a to the 8th, b to the 20th. Simplify, leaving in radical form. So I'm still going to have the radical 3 left over probably. When I simplify this, cube root of 64 is 4. So that's easy. Cube root of a to the 8th. Well, that's the same thing that we had in number 1. I need a group of size 3. So cube root of a to the 8th, I've got 2 groups of size 3 with 2 a's left over. So a couple of ways you can go about this. You can write out 8 a's, 1, 2, 3, 4, 5, 6, 7, 8. And you can circle groups of 3. Or you can take 8 and you can start subtracting 3. All right, 1, 2, there's 1 a, there's 2 a's, and then that is a left over. So that's why you've got 2 a's on the outside and 2 a's left on the inside. All right, b to the 20th. So b to the 20th, so 20 subtract 3, and you can do this over and over and over again. 17 subtract 3, 14 subtract 3, yada, yada, yada. Or if you know your multiples of 3, you know that 20 is made up of 18 plus 2, and 18 is 6 groups of size 3. So using our multiplication tables here, 18 is 6 groups of size 3, so we've got b to the 6th, and then we've got 2 b's left over, which is what you would get if you continued this -3 pattern. And we're done with number 2. All right, number 6 is next. Number 6 is another simplified problem. 25x to the -4th, y to the 6th to the 1/2 power. Now, we're going to do a few things differently here with number 6. First things first, it doesn't say leave it as a radical or leave it as an exponent. So I'm going to go ahead and do some PEMDAS here, which is going to simplify this -4th power. You are not allowed to have negative exponents. What we do is we rewrite any base with a negative exponent in the numerator or denominator, whatever the opposite is. So x to the -4th, that's up top. To make it +4, I write the x to the 4th in the denominator. This is all still raised to the 1/2 power. All right, next, because I know how to deal with radicals, but I'm not quite so comfortable with 1/2 powers, keep in mind 1/2 power is the same thing as a square root. Okay, 1/2 power is the same thing as a square root. So I can just go in and say square root of 25y to the 6th all over x to the 4th, 5y 3x squared. Okay, square root of 25 is 5. Groups of size 2, I have 3 groups of size 2. Groups of size 2, I've got 2 groups of size 2. All right, so there's number 6. And lastly, number 10. Square root 1, 5, 6, 2, 5. Yikes. A is the 27th, B to the 64th. All right, so yet again, I'm looking for groups of size 2. And since I'm looking for groups of size 2, I'm going to actually check my handy dandy calculator over here just to see if 15625 has a square root. And it does. Yay, 125. All right, so the number is done. Square root of 15,625 is 125. And then a to the 27th. Well, here's what I'm going to do for my a to the 27th. That is a to the 26th and a1. The reason I did that is because groups of size 2 or half of 26 gets me a to the 13th. And then one sad a did not get to come out. B to the 64, well, that's b to the 32nd. All that I did was divide 64 by 2 to figure out how many groups of size 2 there were. All right, so there's our first video, 1, 2, 6, and 10. And I will pick back up with 3, 4, and 9.